When most of us think about private aviation, we probably picture a standard Gulfstream, right? Well, today we are looking way past the gold plating and crystal chandeliers. We're examining the staggering physics and structural reality of the world's most luxurious private jets. We're talking top-secret decompression suites on Royal VIP aircraft, surgical-grade flying hospitals, and commercial wide-body mega machines that have been completely gutted and engineered into actual flying palaces.
So here's a question for you. How do you safely install a solid marble bathtub at 38,000 feet? I know it almost sounds like a punchline to a joke, but that is the exact extreme engineering challenge we are tackling today. We're going to break down exactly how aerospace engineers solve these seemingly impossible physics problems of weight, gravity, and atmospheric pressure to deliver just unprecedented luxury in the skies. To really understand how these aircraft are modified, we first got to look at the canvas these engineers are working with, which is roughly 4,500 square feet. We are talking about massive wide-body platforms like the Boeing 747-8, also known as the BBJ, and this gives structural engineers a frankly staggering amount of floor space to manipulate. To put that massive scale into perspective for you, that is significantly more space than a sprawling luxury apartment in Manhattan. But obviously, unlike an apartment, this space is hurtling through the stratosphere at hundreds of miles per hour. So every single square inch is ripped down to the studs and rebuilt completely from scratch to satisfy the demands of owners who have truly unlimited budgets. Section 1. Engineering the flying spa, the weight of luxury. Safely installing a solid marble bathtub mid-flight is just a mind-boggling physical problem. It requires meticulous planning across 3 really critical areas. First up, weight distribution is absolutely paramount. You can't just drop a solid block of marble in there and compromise the aircraft's center of gravity. Second, atmospheric and water management. This is huge. At 38,000 feet, cabin pressure fluctuations wildly alter fluid dynamics, so engineers had to design these complex pressurized plumbing systems with specialized anti-sloshing baffling. That way, the water behaves predictably even under heavy turbulence, because a catastrophic leak could literally short out vital avionics. And third, they need intense structural reinforcement beneath the tub to handle the immense G-forces of takeoff and landing. And the crazy thing is, the tub is just the beginning. Add in heated floors, a complex rain shower system with multiple heads, and, incredibly, a small sauna. Just think about the immense heat and moisture management challenges of putting a sauna inside a pressurized metal tube. It requires heavy-duty vapor barriers and rapid extraction ventilation systems. But when they pull it off, you've successfully engineered an environment where a billionaire can literally sweat out their stress at cruising altitude. It's wild. Moving on to Section 2, Acoustic and Digital Extremes, Stabilizing the Unstable. $1 million. That is the cost of a single custom-built Steinway grand piano engineered specifically for the skies. This is not your standard instrument. It was heavily modified and structurally reinforced to handle the intense stresses, the vibrations, and the severe dryness of high-altitude flight. And get this piano sits inside a 747's custom concert hall. It features acoustically treated walls, seating for up to 20 people, and allows a classical music enthusiast to host an intimate, flawless performance right over the Atlantic Ocean. This really brilliantly illustrates the massive contrast between what we might think of as luxury and actual billionaire reality. While commercial first class gives you, a 23-inch screen, these custom jets feature completely soundproofed, independently climate-controlled cinemas with 110-inch curved screens and Dolby Atmos audio. And the dining? It upgrades from reheated meals on fold-down trays to professional kitchens with induction cooktops, convection ovens, and custom Italian leather chairs. It is a total top-to-bottom reimagining of the cabin environment. And the digital engineering is honestly just as intense. One gaming industry entrepreneur actually had a custom PC rig structurally stabilized against flight turbulence. But beyond just the physical stability, engineers installed redundant satellite internet connections and massive, uninterruptible power supplies. This guarantees absolutely zero lag and zero disconnections. So the owner can seamlessly compete in high-stakes online tournaments while crossing entirely different continents. No dropped frames up there. Let's dive into Section 3, High-Altitude Medical Facilities, Airborne Life Support. This is where we get into some really intense engineering, looking inside the highly classified decompression suites of Royal VIP aircraft. Now, you can't just put a standard, incredibly heavy MRI machine on a plane. The massive magnetic fields would severely interfere with the aircraft's fly-by-wire systems and avionics. It's basically a fatal physics problem. So instead, aerospace engineers have to design bespoke MRI-compatible areas. These are heavily shielded, structurally reinforced zones that use highly specialized alloys. They're engineered specifically to house imaging equipment safely, keeping all those magnetic fields far, far away from the cockpit's highly sensitive instruments. This level of engineering transforms wide-body conversions into literal flying hospitals. We are talking about fully equipped surgical-grade suites and highly classified decompression chambers designed for treating altitude sickness or diving complications mid-flight. These suites feature advanced life support systems that are integrated directly into the plane's dedicated oxygen generators and electrical grid. Plus, they include dedicated quarters for traveling medical staff. These highly engineered suites ensure that VIP owners have immediate, life-saving interventions seamlessly available to them, literally anywhere on the globe.
All right, Section 4. Airborne garages and stables, transporting the priceless.
To pull this next feat off, engineers literally turned to the belly of the beast. One Middle Eastern prince had the entire lower cargo deck of his Airbus A380 completely gutted and converted into a functioning drive-in garage. Engineers had to install special hydraulic lifts and heavy-duty kinetic securing systems to safely anchor a Rolls-Royce and a modified SUV. This setup ensures that over 10,000 pounds of luxury metal remain perfectly static, even if the plane hits violent turbulence.
But perhaps even more extreme than transporting luxury cars is the live cargo. It's actually kind of an open secret in aviation. The horses fly better than most humans ever will. No joke, a Saudi prince commissioned an actual flying stable inside his jet for his prize-winning Arabian horses. This required engineering special shock-absorbing padded stalls, a heavily customized ventilation system to rapidly cycle the air quality and manage odors, and even a dedicated veterinary area just to monitor the animal's stress levels mid-flight.
Which brings us to Section 5, the price of perfection, sustaining the Sky Palace. $200 million. Let that sink in for a second. That is the estimated cost of just customizing the interior of one Middle Eastern royal family's 7478. That staggering price tag covers 5 separate luxury suites, gorgeous Italian hand-carved woodwork, and a master suite that features an actual rotating king-size bed. And remember, that $200 million, that doesn't even include the hundreds of millions required to purchase the base aircraft itself. But here's the kicker. The upfront cost is really just the entry ticket. Keeping a flying art museum or a mid-air marble spa operational means spending millions annually on this financial upkeep list. You've got the continuous custom maintenance on highly bespoke systems, hefty salaries for elite flying and medical crews, the truly massive fuel consumption of a wide-body jet, specialized hangar fees, and, of course, heavy aviation insurance. Really, some of these owners spend more on annual maintenance than most people will earn in an entire lifetime. Which leaves us with this fascinating final thought. When aerospace engineering can successfully conquer the physics of installing a solid marble spa, a soundproof concert hall, and a surgical-grade medical suite at 38,000 feet, what boundaries even left to push? As these billionaires continue to demand the absolute impossible, what on earth will aviation engineers think of next? Thanks so much for joining me on this explainer. I really hope this gave you a whole new appreciation for the hidden physics of the skies.